Right, I'm going to make this my last one. So the empirical formula I'm going to work with in this video, remember we get given this, is C2H4O, and my molar mass I have figured out in this case is 88 grams per mole. Now this one's a little bit trickier. So even though the process is the same, once we've got this empirical formula stuff sorted out, we really need to be good at our isomers. So the formula mass for C2H4O, 2 times 12 is 24, plus 16 for an oxygen is 40, plus 4 makes 44 grams per mole. So I'm feeling pretty good about this because I know that 88 divided by 44 equals 2. So I know that my molecular formula is going to be 2 times this. So it's going to be C4H8O2. Okay, so far so good. So now we need to look at our possible isomers for C4H8O2. So let's go for the easiest one. So we are looking for something with 2 oxygens. Now the tricky thing about this one is that there's more than one possible functional group that has 2 oxygens. Now one note that we do have to make is that for this standard you will only be getting one functional group in your molecule. So you won't have, for example, a ketone in the middle and an alcohol at the other end or something like that. So the most obvious one, I think, is going to be our 4 carbons and a carboxylic acid group, which has our 2 oxygens. Looking at that number of hydrogens there, it obviously does mean there's some kind of double bond, but this C to O here, this carboxyl group, as it is part of here, actually gives us that double bond because it takes away some hydrogen. So 4, 5, 6, 7, 8. So that is very simply butanoic acid. Okay, so versions of that, let's just stay with the carboxylic acid functional group and let's just put a methyl in that chain. So I'm going to reduce the chain length by 1 and I'm going to take the carbon I took off that end and I'm going to put it there. Okay, so that is methyl propanoic acid. I do not need to give the methyl a number because there's only one place it can go. All right. Okay, that's the only 2 carboxylic acids that we can possibly have, but we could have an ester. Okay, an ester has a double bond in it, so it's going to reduce the number of hydrogens and it also has 2 oxygens. So let's make our most simple ester. So we're going to have 2 carbons here and 2 carbons here. So we've got 2 carbons on each side. So this is ethyl ethanoate. Now if you can't remember how to name these, go and have a look at my video on naming esters. Now with esters it's actually quite easy because all you need to do is you need to change the number of carbons on each side, but you still need to have a total of 4. So I've got 2 on this side and 2 on this side. So let's go 3 and 1. Okay, 1, 2, 3 and 1. Okay, so that one there is methyl propanoate. Okay, methyl propanoate. Okay, let's do the reverse now. So we had this molecule here had 3 carbons with the double bond to O and 1 on the other side. So let's do 1 and 3 now. Okay, so we're going to go, that's our 1. That's our ester functional group, 1, 2, 3. Okay, that's an H there, 1, 2, 3, 4, 5, 6, 7, and 8. So that one is called propyl methanoate. Now those are the 3 main esters that you could have. However, there is a tricky one that possibly could come up, so I am going to show you that. And that's a version of this last one here, where instead of attaching to the oxygen, the end carbon, we attach it through the middle carbon. So I'm just going to draw my methyl again, because it's irrespective of that, and my ester functional group, my methanoate. And I'm then going to take this chain and I'm going to draw it like that, so that you can see that the middle carbon is attached to the oxygen. Now that's actually got a weird name, and we don't need to name it, so I'm not going to name that for you. Probably the most common name for it is isopropyl methanoate, but that's a trivial name, and I think isopropyl methanoate, so don't worry about that at all. Okay, so let's just recap. We started with an empirical formula of C2H4O, a molar mass of 88. We worked out that we had to multiply that by 2 to get the molecular formula, and we found 1, 2, 3, 4, 5, 6 possible isomers, each of them with only one functional group. Remember, you'll only be getting one functional group. These 2 carboxylic acids, these 4 esters.